Let's take a look at why it's important to monitor your application and what resources you should monitor and how you should go about troubleshooting performance for your application. When you monitor your application and gather metrics, you can make improvements to the design of your application, increase reliability, detect and fix security issues, and reduce usage costs based on usage patterns. Monitor to analyze long-term trends and answer questions such as, how fast is my database growing? How many users have I added in the last 4 quarters? And so on. Monitor to compare results over time or between experimental configurations. For example, is the site slower than it was last week? Are requests served faster with Apache or Nginx web server? Monitor to raise alerts when something is broken and should be fixed urgently, or something is about to be broken and can be addressed preemptively. Monitor to perform ad hoc retrospective analysis. For example, the latency of your application just increased sharply. What else happened around the same time? Identify APIs and resources that you want to monitor. For example, there might be public and private endpoints that you want to monitor, or multi-cloud resources such as Compute Engine VM instances, cloud storage buckets, Amazon EC2 instances, and databases that you want to keep your eye on. Here we begin to touch on Google's Site Reliability Engineering or SRE principles. I strongly urge you to check out Google's SRE book online. It's available for free. A service level indicator is a quantitative measure of some aspect of a service. A service level indicator might be a predefined metric or a custom metric such as a logs-based metric. A service level objective is a target value or range of values for a service level. Service level objectives should include tolerance for small variations. Absolute limits will result in noisy pagers and require you to constantly tweak thresholds. For example, latency is a service level indicator. You can set a service level objective indicating that 99% of requests over 30 days have latency less than 100 milliseconds. This is a great example of a service level objective that has a range of values for a service level. After you identify the resources to monitor and define service level indicators and objectives, you can create dashboards to view metrics for your application. Create dashboards that include the 4 golden signals. Latency. This is the amount of time it takes to serve a request. Make sure to distinguish between the latency for successful and unsuccessful requests. For example, an HTTP error that occurs due to a loss of connection to a database or another backend service might be served really quickly. However, because an HTTP 500 error indicates a failed request, including 500 errors in your overall latency might result in misleading metrics. Traffic is a measure of how much demand is placed on your system. It's measured as a system-specific metric. For example, web server traffic is measured as the number of HTTP or HTTPS requests per second. Traffic to a NoSQL database is measured as the number of read or write operations per second. Errors indicate the number of failed requests. Criteria for failure might be anything like an explicit error, such as an HTTP 500 error, a successful HTTP 200 response, but with incorrect content. Or it might be a policy error. For example, your application promises a response time of 1 second, but some requests take over a second. Saturation indicates how full your application is or what resources are being stretched and reaching target capacity. Systems can degrade in performance before they achieve 100% utilization. So make sure to set utilization targets carefully.